We have another example, x squared over x squared minus 9 plus 9 minus 6x over x squared minus 9. I want to add these expressions together. They have the same denominator, so I can keep the same denominator, x squared minus 9, and I add the tops, x squared plus a 9 minus a 6x. And it looks like I could be done unless there might be a common factor in there somewhere. And that's what I'm going to have to kind of play around with to see if that's a possibility. And it looks like the top might factor, but I'm going to have to rearrange some of the terms just to see the factors the way I like to. So x squared minus 6x plus a 9. And the bottom is an x squared minus a 9. All right, let's factor here. The top one does factor. It factors to x minus 3 and x minus 3. And the denominator factors to x minus 3 and x plus 3. So, looks like I'm fortunate. I found some factors that are common on the top and bottom, essentially a clever version of 1. So those cancel out, and I'm left with an x minus 3 over an x minus 4. And I'm all done. Sometimes I want you guys to be aware of this. Some students look at a problem like this or at the end of it and say, whoa, what about if I cancel those x's out as well? You know, maybe those x's cancel and I'm left with negative 3 over negative 4 or just 3/4. We are unable to cancel something that's part of an addition or part of a sum. So you want to be careful with that. If the x was multiplied somehow, then maybe we have some options. But since it's part of a summation, we are unable to yank him out by himself. So our solution has to remain x minus 3 over x minus 4. Watch out for that. That's going to trip some of you guys up. It's going to trip me up once in a while too if I'm not very careful.